Hello everyone, welcome to Tech on Cloud. This is your host Abhishek Kushwaha and I am back with another interesting series which is Docker Fundamentals. So this would be approx 10-day series and I would be posting videos every day and we would be going through basic Docker concepts and fundamental knowledge about what the Docker is and why do we need Docker, then how to write a Docker file, different mapping techniques. We will also go through the Docker commands. So stay tuned and learn with Tech on Cloud about Docker in this series. So this is the first day and this is the first lecture of the Docker fundamentals, and I would be covering three basic questions in this lecture, which a very newcomer to the Docker would be having, that why do we need Docker and what are containers, because Docker is all about containers. Okay, then what Docker can do. So before moving forward, just take a let us take a brief introduction that what the Docker is and why it is used. So if I say in simple terms, Docker is a software platform that allows you to build, test and deploy applications very quickly. Okay, Docker packages the software into standardized units called containers that have everything the software needs to run, including libraries, system tools, code, runtime, everything with which a software needs to run. Okay, so this is what the Docker is. We will be covering it in more refined way in the coming lectures. Okay, so let's move to the first question, that why we need Docker. Okay, so let me take you to one diagram, this one. So this is basically a very brief knowledge for an application. Okay, suppose we want to build an application, we require this much things: a hardware, a OS, not a build application, we want to run an application, we need these things: libraries, dependencies, OS, hardware, services, server, database. So suppose we want to develop end to means we want to set up an end-to-end stack including various technologies like this server, then database, then service 1, service 2. So service 1, we can have a messaging system, something like Redis. Then service 2, we can have orchestration tools, something like Kubernetes. Okay, as you can see, this arrows marks the dependency. Okay, we can say that compatibility, whatever you can take means it depends upon some dependencies, operating systems and hardwares. Okay, then we have certain challenges before Docker, means this is the concept which is I am talking about is before Docker is introduced. Okay, so while setting up this stack, we had a lot of issues developing application with all these technologies. Okay, so the first thing was the compatibility and dependency. If you go into the slide back and if we see, we have the first point which talks about compatibility and dependency. So this is what I am talking about in our diagram. So the compatibility with the underlying OS. Okay, so what happens, this technologies which are server, database, sometimes they are not compatible with the with underlying operating systems, and the version is also not sometime it happens the version is also not compatible, means the previous version is compatible with the operating system and the newer version is not compatible with the hardware or something like libraries and dependencies, anything it can be. So secondly, there is the compatibility between their services and libraries and dependency on the OS. Okay, that means one service requires one version of the dependent library where another service requires another version. Okay, means this service may require some other version of the libraries and this service may require another version of the libraries. So this is very tough to maintain and decide which version is to be used for developing an application, and it is very time taking process to find the correct technology which is compatible with the underlying operating systems, libraries, dependencies, and also the hardware. So it was very tough to maintain this end-to-end stack easily. Okay, now if suppose we however we build this stack, means we have prepared this application and our application is ready, but we need to roll out an update, and update is causing some error because of this dependencies compatibility. Okay, so due to this various compatibility and dependency issues, we have very complex architecture for the application. It is not so similar because of this compatibility and the dependency concept. Okay, then what happens if we want to upgrade a new version of the components, or suppose we want to change the database or service or Kubernetes orchestration platform, which is the service 2, then we have to go through the same process of checking compatibility between various components and underlying infrastructure. Okay, what I mean to say is that suppose we want to upgrade this service 1, then we have to follow whole setting up process to see whether all things are compatible with each other. Okay, so the underlying infrastructure issue is usually very complex. Okay, next suppose now however we have our application running and we have set up things, and the developer somehow a new developer enters into the team. Okay, so it would be very difficult for a developer to set up things from start, and they have to follow large sets of commands and instructions to finally set up the system, and they have to also make right choice of the operating systems. Okay, and the right version of the components. So it is very hell of things for the developers. With previous, the Docker was introduced to build an this architecture, or we can say that application. When setting up this end-to-end stack and building an application was very difficult and complex before the introduction of Docker. Okay, and suppose the application is ready, then we have to see that we have different testing environments, so they are compatible with them also. Okay, so sometime it may be happening that someone is using another version and we couldn't guarantee the application that we are building would run the same way as the different environments. So this type of architecture was to be thoroughly checked or tested in different environments to make sure, yeah, it will be working when it will be going to production. Okay, so this is all about compatibility and dependency. Then long setup time. So then we have the second part, which would be long setup time. So this point says that like I said earlier, when the new developer comes up, they have to run and start things from scratch to set up their environments and all, and they have to run hundred of commands to be compatible with the architecture. Okay, then different environment for testing, I covered that also, which means that we had different development and test production environments. One developer may be comfortable using one operating system and the other may be using another one, so we couldn't guarantee that application we were building would run in the same way in the different environments. Okay, so that's why we need Docker. So Docker will be reducing these 3 points basically, which is compatibility, that the setup time using Docker is very less, and there would be no issue of any underlying OS. Okay, because a Docker container shares the same the image the OS kernel with it, so the Linux based image would be favorable with all the versions of the Linux. So it is time saving and it is easy with Docker. Okay, if you have any questions, just comment it out in the comment box. I will be responding you and try to explain your questions. Okay, then next move to the next question, what it can do. So as I said in very starting of the video, Docker will be containerize the applications. Okay, and the e-service will be running with own set of dependencies in isolate containers. Okay, if you want to see how it is done, then let's move to the another image, which is this. So this is what I am saying through what Docker can do. So if you see the previous architecture before Docker was introduced was something like this. It is well of complex. Okay, then we are seeing this architecture when Docker is introduced. Okay, so the thing is, Docker will be containerize each service. So and it would be isolated in the form of a container. So if you see, we have the containers. We have these 4 containers which have the 4 stacks which they are running, the technologies which are web server, database, service one which is our communication system, messaging system which is Redis, and we have service 2 which is Kubernetes, and they have their own set of libraries and dependency. They have not to rely on the means they don't have this others dependency and libraries. They have their own set of dependencies, so it would be very easy for them. Then we have service. Similarly, they have their own set of libraries and dependencies, and if you see, we have the hardware infrastructure at the last, then the OS is installed on it, then we have a Docker installed on it. Okay, so with Docker you will be able to run each component in a separate container. So this facility is provided by the Docker, which is having the containers where each services are being run separately with their own libraries and dependencies. Okay, all are on the same virtual machine and the same OS, but different separate environments or containers. Okay, to run this, what we have to do, we have to just build a Docker image and we have to run it. Okay, it is not compatible like it is very compatible with the underlying OS. We have to not depend upon and check the compatibility with the OS, like we have to you see here in the very first architecture, which was before the introduction of the Docker. Okay, so I hope you all understand what Docker can do. Docker can containerize the services and technologies into the form of containers, separate containers. Then it can be run on each OS, we can say at any OS, without any dependency, without any compatibility issues. uh, they will be having their own set of dependencies. Okay, now let's move to the third question: what are containers? So containers are isolated environments which are isolated. Okay, then they have their own set of processes, services, network interface and mounts. Okay, then they share same OS kernel. So the same OS kernel is the thing which makes a Docker to have they have same OS kernel may have means they make Docker independent in the term of the OS dependency. Okay, so so the containers they are completely isolated, means you will be understanding what the isolated means. They are within themselves, they do not depend upon each other things. Okay, and this have their own set of processes, their network interfaces, everything which is required, they have their own. Okay, then sharing the kernel is very interesting thing in Docker, that if we see containers being run on the Docker, then all means let me explain in a simple way. If underlying OS is Ubuntu, then Docker can run container based or another distribution like Debian, Fedora or CentOS. They can be run using the same kernel. Okay, we do not need to fetch another dependency or something like that. Each Docker container only has its additional software that we just talked about the previous slide. Okay, then there would be thing coming in your mind that what is an OS and that do not share the same OS kernels. Okay, so there is only one remaining Windows which do not share the same OS kernel. So it is not like that we will not be able to run Docker on that. We have to required to install the Docker for the Windows. Okay, yeah, but we will not be able to run Linux based containers on a Docker installed in Windows. Okay, we would be requiring the containers with Windows kernel. Okay, now let's move to another image to understand that. Yeah, so these are containers. Containers are isolated environments. So this if you compare with the previous architecture, this would be services or technology stacks, whatever you consider them, and they have their own set of process, networks, mounts. Okay, so if you see bottom, it is their OS kernel. Then there is a Docker. A Docker makes the OS kernel independent. Okay, so this suppose this OS kernel is Linux based, then these containers would be Linux based containers. Okay, they will not be feasible with the Windows kernel. Okay, and the advantage is that we have, if we use Linux containers, then they are supported, or we can say that they are compatible with another set of Linux softwares, operating systems like Fedora, CentOS and all. so we have to not worry about that. Okay, then this is we came to the end of this first day in Docker's fundamental series. And yeah, uh, this is all for the first video. We will be seeing more things in the next video, which would be like difference between a virtual machine and a container, then how we install Docker in system. Okay, but if you like the first lecture, please subscribe my channel, like this video, and share it with your friends, and hit the subscribe button along with the bell icon to stay updated. And I hope everybody would be going to love this Docker fundamental series by Tech on Cloud. Okay, that's all for today, guys. Meet you tomorrow with the day 2 of the Docker fundamentals. Till then, bye bye, take care.